Assalamualaikum, my name is Atika and my metric number is BE1030318. I'm from Group 11. We will present about our project assignment is electrical circuit. For my group, I have 3 members. First is Alia Shafika, second is me, Atika, and lastly Muhammad Ali. Okay, for introduction, our aim for this project is to learn how to solve each task given using formula rule that we have learned in electrical circuit 1. Next, to give comprehensive understanding of electrical circuit fundamental, especially nodal analysis, mesh analysis, and other basic theorem involved in the task. For the objective for this project is to know how to make calculation by using nodal analysis and mesh analysis that we have learned in chapter 3. And conduct a simulation using multi-sim software. At the same time, we are able to know how to design a circuit based on a technical problem given. For the task 1, I will give to Alia to explain how we solve the task.
So, we are given task 1, which is students are required to do a calculation using a nodal analysis and the mesh analysis for the circuit given. For nodal analysis, students are required to find all the node voltage, and for the mesh analysis, students are required to find mesh currents for the circuit. So, this is for nodal analysis, which is we need to find at the node V1 and node V2. For node V1, we find it by using KCL, which is Kirchhoff current law. And the answer that we get for equation 1 is 30 V1 minus 7 V2 equal to 8. And for V2, we got minus 7 V1 plus 11 V2 equal to 64. So in order to get V1 and V2, we need to make it into a metric form, which is we make it into 30 minus 7 minus 7, 11 in the bracket V1 and V2 equal to 8, 64. And the answer that we get is V1 equal to 5.7 V and V2 is equal to 9.45 V.
For task 2, we need to do the simulation of circuit to prove our calculation is right. As you saw at the circuit first, I do the simulation of nodal analysis at point V1 and V2 as shown in this video. So I use a multi-sim to prove it. As Alia mentioned in task 1 calculation, for nodal, we get V1 is equal 5.7 volt and V2 equal is 9.45 volt. So at the simulation, I get exactly like the manual.
Next is mesh analysis. As you can see, here we got 4 loop, which is loop 1, we got I1 equal to 2A, and for loop 2, we need to use KVL, which is Kirchhoff voltage law, to get the answer. So the answer that we get is minus 8 equal to 9I2 minus 4I4. For the loop 3, we got I3 equal to 4A, and for the loop 4, we use the same way like we find in the loop 2, which is using KVL. And then the answer that we get is 4 equal to 7I4 minus 4I2. In order to get the answer, we need to use the metric form, which is 9 in the bracket 9 minus 4 minus 4, 7, close the bracket and open the bracket, I2 I4 and equal to minus 8, 4. So the answer that we get is for I1 is 2 ampere, I2 is minus 2.85 ampere, I3 is 4 ampere, and I4 is 35.1 milliampere.
After I get value for nodal, I remove the probe to find the value for mesh analysis. which is we know in current. As you can see in this video, I put the probe to measure current, follow the current flow. So for I1, I get is 2 ampere, I2 is negative 2.85 ampere, I3 is 4 ampere, and I4 is 85.1 milliampere. For I2, I get the value is negative 2.85 ampere is because the loop of current in clockwise.
Okay, I will explain about task 3. First of all, for step 1, combine the resistor 6 ohm and 3 ohms. Next, by using source transformation, combine the current 2 ampere with resistor 16 ohm. After that, for the step 2, redraw the circuit, then combine the resistor 16 ohm with 20 ohm, and also 2 ohm with 10 ohm. Next, combine the voltage source. For step 3, simplify the voltage source with series resistor. Then combine source transformation and resistor, which is 24 volt with 36 ohm by using Ohm's law formula. For step number 4, redraw the circuit, combine 36 ohm with 12 ohm resistor. Furthermore, combine the current and resistor which is 0.667 ampere with 9 ohm. For step 5, calculate the R total, which is 9 ohm plus 12 ohm plus 7 ohm, and then combine the voltage source 6 volt with 36 volt. For the last step, the value of current that given is 2.58 ampere. Next, by using Ohm's law formula, we can calculate the value of V0. The value of V0 is 28 volt.
Next, for task 3, it actually doesn't need we to make the simulation, but to prove our calculation, we do the simulation. As you can see in this picture, I use voltage source voltage in multisim to find the value VO. So first, I connect the VO and resistor R7. Then I open circuit and put multimeter for the current between R7 and voltage source, and another multimeter to measure the VO. So I set the voltage gain 1.6 volt to get current 2.5 ampere as stored in task 3. So I get the answer for VO is 28 volts, same like manual calculation.
Analysis and discussion. We are able to study the method of nodal analysis and mesh analysis for task 1, circuit design for task 2, and source transformation by KVL, which is Kirchhoff voltage law, for task 3. For task 1, we were able to apply the nodal analysis method to do the calculation for the circuit shown in figure 1. For task 2, we using the multisim software to design and simulate the circuit. As shown in simulate, the value we measure in same as theory calculation. For task 3, we were able to apply the source transformation in the circuit. Then we need to find the value V0 in the circuit. The current of the circuit that's given is 2.5 ampere. We must simplify the circuit using source transformation into single mesh and write the KVL equation. For simulation circuit task 3, we use a voltage control voltage source to find the value of V0.
So for the conclusions of this project is we have learned that on how to analyze the circuit, and next we are able to apply the knowledge that we learned such as mesh analysis, nodal analysis, and source transformation. Then we also learn on how to run the circuit using the multisim software. And for last, we are able to apply all the knowledge that we learned for this subject to complete this project. Thank you.